Welcome back. In last class, we discussed about the coupling schemes, and the next topic is forbidden transitions and selection. We have already mentioned that the electronic transition takes place between two levels when there is an interaction between an external electromagnetic radiation. And we can see that this electromagnetic radiation interacts with a given atom or molecule, whatever may be, in different ways. So, in that interaction, if the electric field vector of the external electromagnetic field interacts with the atom through the electric dipole moment of the given atom, there can be a transition. In another way, this electric field can interact with the electric quadrupole moment of the atom, or the magnetic field in the electromagnetic radiation can interact with the magnetic dipole moment of the atom or magnetic quadrupole moment of the atom. So there can be such transitions. But the most probable transitions that we are observing is the interaction of electric field in the electromagnetic radiation with the electric dipole moment of the atom. This is the most common way we are observing. And there may be possibility for such interactions. But it is found that since such interactions are less probable, their intensities will be very, very small. So, for such these transitions, we can have selection rules, and we can have the selection rules for delta J, delta L and delta S. And for the electric dipole, then electric quadrupole, then magnetic dipole. The delta J change, as we have discussed in the previous section, for the electric dipole moment case, or the interaction of electromagnetic radiation with the electric dipole moment of the atom, the selection rule for the transition is delta J can change either 0 or plus or minus 1. The same is applicable for magnetic dipole interaction also, 0 plus or minus 1. And delta L, this is same, either 0 or plus or minus 1, and here also 0 plus or minus 1. And for delta S, the value is 0. But a point has to be mentioned here. This transition or this selection rule delta S is 0 is applicable only for lighter elements where you are getting with the LS coupling. In the case of JJ coupling, there is no special mentioning for S because there is no special or there is no separate existence for the spin. There we are only getting or we are only mentioning about the J values. And for the electric quadrupole moments, this value is 0 plus or minus 1 as well as plus or minus 2. Similarly, the same thing for delta L, and for delta S, here also that value is 0. So, if a particular transition is not allowed in electric dipole moment transition, that means if either of these selection rules is not valid, such a transition cannot take place. But If such a transition is taking place between any two energy levels, it can be due to either electric dipole transition or magnetic dipole moment transition. And such transitions are normally termed as forbidden transitions. So, a forbidden transition means that transition can occur, but it is not due to electric dipole, or it is not under the consideration of this electric dipole moment interaction. That means interaction of electric field of electromagnetic radiation as well as the electric dipole moment of the atom. And that about this concept of forbidden transitions. So a transition which is not allowed under electric dipole moment transition is termed as forbidden transitions, and these are the selection rules. And okay, so this is enough about in this topic, and in the next section we can discuss about the spatial quantization, which is also important to discuss the coming topics. So we can stop here and we can have the next class or next video. We will be back. Okay, thank you.